Hello, and welcome to OpenGL Essentials Live Lessons. I'm Dr. Paul Verholic, and I'll be your guide as you discover the exciting world of real-time 3D rendering with OpenGL. I've been a software engineer for the past 20 years, and have spent the last 10 years writing video games. I was a lead engineer at Electronic Arts, where I worked on titles including John Madden NFL Football and Superman Returns. I left EA to pursue my PhD, and I am currently a programming instructor at the Florida Interactive Entertainment Academy, a graduate degree programming in game development at the University of Central Florida. I've been teaching at the college level since 1998 and have taught classes in C and C++, C#, Objective-C, game development, game engine architecture, and real-time rendering. I'm also the author of Real-Time 3D Rendering with DirectX 11 and HLSL, a practical guide to graphics programming, to be published in spring 2014 by Addison Wesley. I'm very excited to work with you as you explore OpenGL. These lessons will introduce you to the modern OpenGL API and real-time rendering techniques. There are 6 lessons in this series, which provide practical, usable demonstrations of OpenGL that can be immediately applied to your own projects. In the first lesson, you'll dive right into the pool and implement your first OpenGL application. You'll examine a C++ application framework and write your first GLSL shaders. Then you'll get into the details of the OpenGL 4.4 graphics pipeline to discover how your applications interact with a modern graphics card. The second lesson is an introduction to the mathematics behind 3D graphics. If you have a general aversion to math, don't panic. The material is presented in a straightforward fashion that attempts to minimize math anxiety. In Lesson 3, you'll learn about providing input to GLSL shaders and passing data between shader stages. You'll author a number of OpenGL applications and dive into the details of using OpenGL buffers for vertex and index data. You'll also learn about loading and rendering 3D models, and you'll integrate a third-party library for importing models from a variety of file formats. Lesson 4 is all about textures. You'll learn about loading textures and mapping them to 3D objects, and you'll learn about various texture wrapping and filtering modes. In Lesson 5, you'll implement lighting for your 3D scenes. You'll hear about ambient lighting and diffuse lighting, specular highlighting, and about directional lights, point lights, and spotlights. In Lesson 6, you'll implement some more advanced rendering techniques. You'll learn about texture cubes and their applications for skyboxes and environment mapping, and you'll implement systems for fog, normal mapping, and color blending. The lesson ends with a survey of additional topics in modern rendering, with options for where you might go next on your exploration of graphics programming. The survey includes discussion of post-processing, shadow mapping, skeletal animation, geometry and tessellation shaders, deferred rendering, global illumination, and compute shaders. There's a lot in store, and I hope you're excited. But if any of this sounds a little daunting, let me assure you that you can do this. These lessons will start from the beginning, with no expectation that you have a prior background in 3D rendering. If you do, great. Maybe you have used DirectX, XNA, or an older version of OpenGL. But all of the material will be covered in depth with a hands-on approach and a focus on practicality. The only prerequisite for this material is an expectation that you are already a programmer. We'll be using C++ throughout the series, with no in-depth discussion of C++ syntax. I will call out a few C++ 11 language features when they're employed, because these are relatively new constructs. If you aren't a C++ programmer, but are familiar with object-oriented programming and C-based languages like C# or Java, you should be able to follow material with little difficulty. However, all of the coding samples are provided in C++. Similarly, the C++ framework we'll use follows an object-oriented design. Thus, a familiarity with object-oriented principles will help. However, I will do my best to explain the design of the framework and provide rationale for the architecture. OpenGL is a multi-platform library. There are OpenGL implementations for Mac OS, mobile platforms including Android and iOS, Windows, and Unix and Linux operating systems. And there are differences for each platform, particularly between desktop and mobile operating systems. But the concepts you'll learn in these videos will apply to any of these platforms. Thus, I won't be discussing cross-platform development. All demonstrations will be done on Windows using Visual Studio 2013. That said, the code for these videos is open source and could be ported with a bit of effort. Similarly, if you're running an earlier version of Visual Studio, the projects will be portable with minimal effort. Please download the code to work along with the lessons. You'll find the code attached to these videos. Welcome again to OpenGL Essentials Live Lessons. Let's get started.